Now we will do an example about finding the critical points of a function of two variables. So remember from the previous video, the criteria for being a critical point is that either one of the partial derivatives is ill-defined, which again in practice is not the most important for us, and the second one, which is more crucial, which is that both of the partial derivatives vanish. So really what you have to do in most of the problems involving finding critical points is immediately compute the partial derivatives and then just hope that you get a system that you can solve. So let's try to find the partial derivatives. In this case, our function f will be x squared times y plus a third of y cubed minus x squared minus y squared plus 2. So if you find the partial derivative with respect to x, you get 2xy. This term goes away, then you get minus 2x. And the other remaining terms also go away. On the other hand, if you take the partial derivative with respect to y, then you get x squared plus y squared minus 2y. Okay? And so the system that we need to solve, or what we need to do, is find all the points x comma y that satisfy simultaneously both equations. So what we need to do is set up each of these two equal to 0. So let's call this equation 1 and the other equation 2. Let's begin with equation 1 to see what it says. Here you have to be careful. There's a strong temptation, if you take the first equation, to just cancel x, divide by x on both sides. The issue if you do that is that you could definitely divide by 2, but that's another thing. But you can only divide by x if you already know that x is not 0. And x being 0 is a possibility that we definitely need to take into account. So really what you should do is, like, the recommendation is never divide by a variable. So never So instead of dividing by 2x or multiplying by 1 over 2x, however you want to say that, what we would do is factorize 2x on both sides of the... okay, this time there was no glitch, just a very silly typo that I made. Okay, we have to analyze each of the equations. We can start with the first one. For the first equation, there's a strong temptation to divide by x, but that's something you must avoid, because in general x might be 0, and so dividing by x, which is the same as multiplying by 1 over x, may not be allowed all the time. So just remember, like as a precautionary measure, that to not divide by variables. Once you keep that in mind, then you're good to go. In order to figure out what happens with the first equation, you just factorize 2x, and so you get y minus 1 equals 0. So the typo I made before was that I wrote y minus 2, and that screws up the entire problem. And now once you get to this point, there are like two cases. So the product of two numbers is 0 only when at least one of them is 0. So this is sort of like the video games, when you have a storyline that you can make different choices in the game. So now we have there are two paths we can follow that will be completely different. They will not talk to each other. They will carry different information. So there's like some sort of bifurcation. So first we can have the possibility, case 1. So this is like the first alternative in the storyline where x equals 0. Okay? If that happens, then you can substitute in 2, right? And you get 0 squared plus y squared minus 2y equals 0, which is the same as y times y minus 2 equals 0. And again, this bifurcates into two cases. I guess there's some redundancy when I said that, but either y equals 0 or y equals 2. But all of this was within the context of x being equal to 0. So that gives you 2 points, which is 0, 0, and 0, 2. Okay? Now, that's the first thing that could happen. The other option that we can have to deal with is when y equals 1. And again, you substitute now in in 2, and so you get x squared plus 1 minus 2 equals 0. So you get x squared minus 1 equals 0. Or x minus 1 times x plus 1 equals 0. And again, this gives you two possibilities, which bifurcate into the following cases: either x equals 1 or x equals negative 1. But x equals 1 is within the context of y equals 1, so that gives you the critical point 1, 1. X equals negative 1 is within this context, so it gives you negative 1, 1. So we find 4 critical points, which are this, 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 and this.